Good morning, grade 11s. It's Friday, June 5th at 7:43. We will be doing multiplying and dividing rational expressions today, and we'll have a quiz on simplifying and multiplying and dividing pretty soon. I can't remember exactly when. Watch the stream. Okay, so let's get down to it. So, multiplying and dividing rational expressions is exactly the same as rational numbers. Now, when I say rational numbers, I am usually referring to fractions, because all rational numbers are fractions. Remember, a rational number is x over y, and both of them are integers, and y can't be 0. So we know that. Now, if I'm going to multiply x over y times a over b, you know that that answer is going to be x times a over y times b. And similarly, dividing x over y divided by a, I'll use two different colors again, divided by a over b. Now this, you have to remember, is the same as if I wrote x over y over a over b. That gets us x over y times b over a. We have to remember that we multiply by the reciprocal. Now, all of you know how to do this. You've been doing it since the 4th grade, but there's a couple of tricks that I don't know. Every year I show this to kids, and they're like, oh my gosh, I've never seen that before. What are you talking about? That's crazy. And then some other kids like, duh, yeah, of course that's how you do it. So I'll show the trick. So most of you, when you see this, you automatically multiply straight across. So you do 5 times 4 over 8 times 15, which gives you 20 over 120. And then you would simplify this. Of course, most of you would go, okay, well that divides by 2, and that divides by 2, and you'd work your way down eventually to 1/6 by dividing and dividing and dividing. Now, what I would like to show you is this, 5/8 times 4/15. Look, there and there. 8 and 4 both can divide by 2. Or divide by 4, I'm sorry. And 5 and 15 can both divide by 5. So 5 divided by 5 gets me 1. 8 divided by 4 gets me 2. 4 divided by 4 gets me 1. 15 divided by 5 gets me 3. And now 1 times 1 is 1, 2 times 3 is 6. And you can do the reducing, which isn't really reducing, but everybody calls it that. You can simplify here with little numbers, not with big numbers. All right? And remember, it's all just values, no matter what. So, let's have a look at this. Now, pretend we don't know what we're doing. So, the first thing I would say, well, you're having trouble, you don't know what you're doing, but you do know some stuff to do in math. Like every time you see something like that, you should factor. So the first step in this is factor anywhere you can. So I can factor there, I can factor there, but these two are not. So let's factor the first one. I don't really want to use yellow, which was kind of dumb of me, so I'll use orange. How do you factor that? Well, that's a plus 3 a minus 4 over, how do you factor the green one? That's a plus 3, a minus 3 times a minus 3, a minus 1 over 2, a minus 4. Now, look up here. When I had 5 and 15, when I had something on the top that worked with something on the bottom, I was able to cancel stuff out. So, notice I have an a plus 3 in the numerator, and I have an a plus 3 in the denominator. So even though they're not diagonally, I get to cross them out because a plus 3 divided by a plus 3 is 1. So that's gone. Now notice I have an a minus 4 here and an a minus 4 there. One's in the numerator, one's in the denominator. Gone. Then I have an a minus 3 in the numerator and an a minus 3 in the denominator. Gone. What's left? A minus 1 over 2. So that is step 2. Cancel. Cancel common factors. And then there's a third thing we have to check. Check NPVs. And actually the NPVs you have to do before you cancel. Sorry about that. So I really need to check my NPVs there. So A cannot equal plus or minus 3 for that one, and 4 for that one. So sorry about that, ladies and gentlemen. Alright, so let's look at this next one and we'll do it in the right order. Step 1 is factor. So I can factor there, I can factor there, I can factor there, but I can't factor there. So the first one, and I will use yellow, y minus 3, y plus 3. Then I'll use blue. Factor out an r, and I get r squared minus 1. But that factors again, so I'll do that separately. 2, and then in green, r minus 1 over, and then y plus 3 is just y plus 3. Now, this factors again to r plus 1, r minus 1. So now, 2, we do our NPVs. So r cannot equal 0, because if that r was 0, everything would be 0. It can't be plus or minus 1, and y can't be negative 3. And then we cancel our common factors. So y plus 3 gone, y plus 3 gone. Numerator, denominator. R, gone, gone. R minus 1, gone. What's left? Y minus 3 over r plus 1. And there's our final answer. Alrighty. So let's have a look at this one. Again, step 1, always factor. Where can I factor? Not very many places. So factoring doesn't need to happen. So step 2 is NPVs. So r can't equal 0, because if r is 0, 2 pi times r is 0. And d can't equal 2, because 2 minus 2 would be 0. Then 3, cancel. D over d minus 2. Now some of you are going to cancel that d, and I'm going to tell you why that's not okay. D over d minus 2. You cannot do that. And I've shown you this in the past. I'm going to show you again. So just say d equals 1, right? So that would mean this would be 1 over 1 minus 2, which would be 1 over negative 1, which would be negative 1. Everyone should follow that. Now, if you cancel this, you have 1, because you cancel the d, so you have to leave a 1. You can't make it 0, over negative 2. Is 1 over negative 2 the same as negative 1? No. That's why you cannot cancel the d that way. But I can cancel 2 pi r and 2 pi r. And what am I left with? dh over d minus 2. Ooh, I'm right in a sunbeam. This is killing me. Slide over. Sorry. There we go. Okay, well, now look at this one, number 4. What's weird? It's got a division. So what we have to do is we have to remember that this is really x squared minus 4 over x squared minus 4x times x squared plus x minus 20 over x squared plus x minus 6. We have to remember that we reciprocate the second term. Now, of course, that has a name. It is the divisor. It might be the dividend. I can't remember which it is, but you flip the second term by reciprocating. Now we get into our steps, and step 1 is always factor. So I can factor there, I can factor there, I can factor there, and I can even factor there. So I factor everything. X plus 2, x minus 2. Over. Do this one in blue. X minus 4 times, do this one in green, x plus 5, x minus 4, and do the last one in purple or pink, x plus 3, x minus 2. Now, something weird happens in division, and I'm going to put it right here. NPV must be checked. What has happened? Must be checked on both denominator, and numerator. You have to check it on both of these because you can never divide by 0. So if either of these is 0, you're in trouble. So I have to check NPVs on both. Oh, I've put a box around the wrong one. On both of these. So x cannot equal 4, negative 5, 2, and negative 3. So you got to remember to check them both on division questions. And then after that, it's just cancel. X minus 4, x minus 4, x minus 2, x minus 2. And I'm left with x plus 2, x plus 5 over x plus 3. And that's done. 2 more for practice, and then we'll move on. So this one we can see is a division, so we have to remember it is c squared minus 6c minus 7 over c squared minus 49 times c squared plus 7c. Good morning. C squared plus 8c plus 7. Morning. And then I factor. I'll color code again. Let's do it this way. Orange, blue, green, and pink. And they're all factorable. So the orange one first. C plus 1, c minus 7 over pink one, c plus 7, c minus 7 times the blue one, c plus 7 over, and the green one, c plus 7, c plus 1. Then I have to NPV, and I have to NPV both of them because it was originally a division question. So c cannot equal 0, -7, -1. And then I cancel. C plus 1, c plus 1. C minus 7, c minus 7. C plus 7, c plus 7. What am I left with? C over c plus 7. And remember, you're gonna want to cancel this c, but you can't. Okay? And I showed you why earlier. And finally, number 6. What? Division and multiplication? Mr. Myers, you're crazy. But we're going to do it. So we remember it is 2m squared minus 7m minus 15 over 2m squared minus 10m times 6 over 4m squared minus 9 times 3 minus 2m over 1. All right, so let's do this thing. Factor, factor, factor. There's too many colors here, so I'm just gonna, oh, no, I'll do it. So I can factor that. I can factor that. I can factor that. And I can factor that. So let's do this thing. In blue, that is, it's just, I need a second to do it in my head, sorry. Well, I might as well show you. Remember, there's lots of ways to factor that. I personally, it's m minus 5 and m plus 3. Oh, sorry, 2m minus 5 and m plus 3. 2m squared, 6m. No, I'm sorry. That's not right. It's the other way around. It's 2m plus 5, m minus 3. 6m, 2m squared minus 6m plus 5m. No, I'm screwing it up. It's 2m minus 10. So it's 2m plus 3 and m minus 5. 2m minus 15. Minus 10 plus 3. Yep, that's it. There, that's what it is. Sorry. Over. And in green, 2m, m minus 5 times 6 over 2m plus 3, 2m minus 3 times negative 2m minus 3 over 1. Hey, and then we do our NPVs. So we gotta check. We only have to check these two, right? Because that can never be 0, so I don't need to check both of them. So will I, Betty. So our NPVs, m cannot equal 0 because of that, 5 because of that, positive or negative 3 over 2 because of that. And then we cancel. 2m plus 3, 2m plus 3, m minus 5, m minus 5. 2m minus 3, 2m minus 3. And what am I left with? 6 over 2m. But remember, that's a negative 6 over 2m, which you could simplify to negative 3 over m. And then we're done. You do page 170. Okay? I'll see you guys soon. Bye-bye.